StClair is the CEO of Sciatic, a leading African Google Cloud partner, which helps businesses to understand the cloud, migrate to Google Cloud, and manage and support the business journey to the cloud. Brett has over 20 years of experience in the global digital landscape, which includes over 10 years of Silicon Valley experience, where he worked to build African successes at AdMob, Android, YouTube, and Google. Brett has held various executive positions at South African and international companies, including Google Cloud's Regional Manager for Sub-Sahara Africa, Google's Head of Products, and Chief Digital Officer at Barclays Africa. He is passionate about power of scale and how businesses can use digital technology to build exponential growth. Please welcome Brett to the stage.
OMG, am I still wearing the bloody same t-shirt? That's terrible. So, guys, I'm fascinated about 3 letters. I always talk about these 3 letters. They seem to dominate my life, and for the last year or so, it feels like they're everywhere. Does anyone know what those 3 letters could be by any chance? WTF, thank you very much. So is there anyone who's willing to share with me what WTF means? Sorry, you got to shout louder? What the fuck? Yeah, baby. Anyone want to try out of the gutter? What's the future? But you're right, it is also what the fuck. So, why is it? Because everyone, all of us in this room, we sit there day in, day out in the office, and occasionally we sit back in our chairs, and everything seems to be changing. Lots of things are happening very quickly, and we ask ourselves, what the fuck do we do now? I call those WTF moments. And those WTF moments, you're either going to carry on doing what you've always been doing, or you're going to try something else. And that's what I'm passionate about. I feel this year has been one big WTF moment for everybody. What do we do now? So thinking about this year, I wanted to kind of sum up kind of what I think has been happening. When I say this year, I mean last year's cloud conference to this year's. Because lots of things have happened, right? So if we were exiting last year's conference, we were probably thinking to ourselves, you know what? I need to start using cloud technology. I need to start putting some workloads in the cloud. I'll start trying to do all of that. What we also need to do is start using AI and playing around with machine learning. Am I wrong? Quick show of hands. Hold on, does anyone want to do a quick exercise? Just give me a raw, quick exercise. Fuck off, get off. Okay, I want you to put, is it your left hand out, please? Please put your left hand out, everybody. Just very quickly. It's a quick side note. Left hand out. I can see you don't have your left hand out. Okay, everyone got your left hand out. Lift it up to 30 degrees. Whoa! Down, 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 down. Okay, take it to 50 degrees. A little bit higher, sir. There we go. Okay, put it all the way up. Okay, so when I ask you to put your hands up, you now know how to do it. Just kidding. So is that the kind of view, right? And I think what actually happened this year is we all went back to the offices. We put together a cloud team. Said, yeah, you, head of cloud. Person's going, awesome. Me, fantastic. I was doing infrastructure, if I was lucky, maybe a bit of networking. Build a team, great, we're going to build a team. And what everyone did is they sat around and they went to Excel and they started doing TCOs. Let's understand what we have. Let's figure out the real cost and figure out who we're going to move with based on cost. Awesome. Fantastic. And then you had another team. But this team you had to go out and you had to hire. And you hired a bunch of data scientists. And you said to them, okay, guys, you're a data scientist. Now, what I want you to do is here's a small bunch of data. I'm going to give you just a couple of handfuls of data. And I want you to go find me a problem. Go find it. Go solve it. Go find that golden nugget. And, most of the guys sat there going, okay, we'll do our best, and they find some interesting solutions, right? Is that what's kind of happening? Am I on the right path? Quick show of hands? Or do we have to do another exercise? So kind of, right? That's kind of what we ended up doing. Some guys actually kind of did a fairly good job, got fairly far forward, and realized it wasn't a data science job that was needed. You needed to actually start figuring out the disparate data sets that are sitting in your architecture and try to create these silos, or try to break down the silos and create data pipelines. So you figured I'd build a Hadoop stack. Who's running Hadoop? Very quickly. Anyone running Hadoop? I'm not going to laugh at you. Right? We did it because it seemed like the right thing to do. And it is the right thing to do. It's the right thing to start thinking that way, but it's bloody difficult. You're building a sledgehammer for a very small data problem. But that's all we kind of knew. But you took a bunch of data scientists and you made them data engineers, and the data scientists are not very happy. So, where am I going with this? This year, when you leave this conference, you need to formulate a plan. A plan that's based on the learnings that you've had over the last couple of years on what you're going to do. Now, if you're going to formulate a plan, you better understand exactly where this world is going. Because you're going to have to make some investments in time, in resources, changing your financials, because you're going to be investing in OpEx plays. The world is changing. You're going to move quickly. You're going to change how you work. Who can tell me what the world of compute is going to look like in 5 years' time? It's terrifying. 3 years' time. 2 years' time. Right? So how are we going to make these big plans, these big bets, and go back to our business colleagues and guarantee them that we're going to get this right? So I want to kind of help you now. I'm going to put forward what I think is the future. I may be wrong. I might be right. And then I'm going to help you with it by validating why I think this is possibly the future of the compute space. And the reason why I think it's important, because you can add your own points of view onto this and decide if you think you're going to go down that route, and you're going to formulate a plan that you can start accelerating on. This year is about getting the plan into action. It's no longer doing TCOs on spreadsheets. It's about making it happen. So what does the future look like? I love that photo. Does anyone remember the name of the bot? What's it? Wiley. And he's looking to the future, right? And he's just wanting to do tons of workloads. So let's paint a picture, maybe what I thought was 5 years from now. And I think what's going to happen is we're going to see the democratization of compute. What do I mean by that? Compute workloads are going to literally be transportable. They're going to be mobile. You're going to be able to move your workload wherever you want, whether it's on-site, whether it's to another data center, whether it's to a hyperscaler. This workload, which is going to be a small workload, because you're going to have millions of these workloads that you're going to need to manage, is literally going to be transportable. Now, there's going to be a bunch of policies that are going to be tied to this workload. Things like, what latency am I going to accept? What kind of processing power do I need for this workload? What kind of GDPR policies do I want to run on this? Where can I run this workload? Right? Now, what's going to happen is we're going to be in this world of least cost routing. If anyone's from the mobile or telco space, least cost routing is saying, where am I going to find the cheapest, most effective route to route this call? And we're going to do the same thing with compute. We're going to say, you know what, Amazon's running a discount for the next 2 weeks on SSD storage. Boom. Let's take advantage and move the workloads automatically. In fact, you're not going to move the workload. It's going to move based on the policies that you've put in place, the ranges that you want to operate these workloads in. So that's where I think compute's going to go. It's going to democratize the landscape, because it means you can run this compute anywhere. People are going to be building data centers. There's going to be a lot more Terracos because you're going to be able to run it wherever you want. You're not tied to one space anymore. Now, on top of that, you're going to see a different world because now we're going to have to fit in, how do we run machine learning algorithms? And I've got a little story. This actually comes from one of my customers. They're a small business called Resco. They're asset managers. Who would have thought asset managers ruling the world of innovation? And they used a piece of technology called Google Cloud Functions. And they understood that this world of AI and machine learning meant you start with one algorithm that you're training, and you're training. And each session counts as a retrain, right? And they started building more algorithms and training them more frequently. Within 6 months, they had moved from 1 or 2 trains a month to 2 million. They must have a huge IT team, right? 3 people. And they are retraining these engines because machine learning is about the marginal increase, getting that algorithm better and better by refeeding it with the right type of data that fits the problem you're trying to solve. And then what he used was cloud functions. So he started building this event-based architecture. We all know about microservices, right? Take your code, bring it down into a containerizable. Have I got that right? Have I just made a word up? Containerizable. I think that's maybe right. Piece of code that you can scale up or scale down, and you're creating these microservices. If you are not doing that in your code base, please can I suggest you leave right now. You've got a lot of work to do. And start coding like that. But the next level is this event-based. All these different events being triggered the whole time. How do you think a Google runs 1 billion users across 8 different products? Each product has 1 billion users. The amount of different events that are running the whole time. At any one time, they're doing billions of events that are being managed automatically in a serverless world. So you're going to have these 2 worlds. Compute is going to be mobile, and your architecture that's determining how you scale and productionize your world of machine learning and AI is going to be event-driven. What do you think? Did I just make that up? Right? So let's see if I've made it up. Why I think it's going this way. And why it's not going to happen in 5 years' time. Why it's going to happen in 2 years' time. The first building block is here. Who's heard of Anthos? So Google announced something 2 months ago called Anthos. Very powerful. Let me tell you what it does. It will take an existing infrastructure, maybe on site, and you're running a bunch of VMs, right? And everything's going fine, and you see this burst of traffic. Let's take, for example, a huge, say you're running a website, and you do a discount, and the traffic bursts. Or maybe it's month-end reporting, and you start overloading the environment. So what Anthos does is it'll take the VM, within minutes, create and containerize that VM, make it mobile, and start pushing it to whichever hyperscaler you want to run that workload on. Because now it's in a container, and that container can be managed through Kubernetes and scaled up or down. And that'll exist until the traffic loads ease off. Say if it's month-end reporting, it eases off and it kills the traffic. The benefit there is you don't need to buy additional infrastructure. You need to invest in an Anthos platform that can deal with that scale and lift it and shut it down. That's very cool. But now let's think about my prediction. Now we've got a tool that can take any VM and it can turn it into a container and you can move it anywhere. Now all we need is someone to do the billing, the least cost routing, to look at the policy of how you want to run that workload and then let that route it automatically for you. And maybe that's another 2 years off. Maybe that's a startup for one of you guys. Who understands that world? Go for it. Go build it. Suddenly, you're going to have compute commoditizing. The price of storage, the price of compute is going to be collapsing, and it's a good thing. We already have blockchain, which is teaching us this distributed way of managing compute and the algorithms behind that. I think we're going to see a mashup of that. We're going to be using platforms like Google Cloud Functions to manage all these events higher up the chain. Because you're not going to be able to do it manually. You're not going to be able to script it. It's no longer doing batch jobs. You're triggering one event to another event, dealing with tons of microservices. So I'm going to leave you with 3 steps. 3 steps to kind of help you formulate the plan. You now know what the destination is, but what kind of steps can you actually tangibly take away from today? Have you guys had a good day, by the way? Not bad, right? You're going to take away from today, and you're going to give it a bash. So the first step is stop faffing. Who faffs? Any faffers? I faff a lot. So stop faffing. What I mean by that is stop sitting there worrying about pricing calculators and trying to figure out what architecture is best going to suit you, and go and do it. I've got the best example of it. And when I say do it, run a benchmark. Pick a system. Any system. Pick it. Maybe the easiest is a reporting system of some sort. Lift and shift. Take a snap of that on-site environment. Take a snap, go put it on Amazon, go put it on Azure, and go put it on Google. And it'll take you a couple of days, guys. The technology's there. You're not going to need to plan for a long time. You're going to take the snap, you're going to put it up there, and you're going to run exactly the same scripts. And you're going to be checking the following things. You're going to be checking price. You're going to be checking performance. You're going to be checking the size of the architecture that you're running, and if you can scale down the nodes so you can save on other licensing costs. I actually have a customer, great customer, PPS. Everyone familiar with PPS? I didn't really know about him because I don't have a degree. I wish I did have a degree after seeing the policies they offer. Amazing. So what they did a similar thing. They said, damn it, we're just gonna run the same environment that we've got on site, and we are going to put it into multiple cloud spaces, and we're going to run it. If I give you a sneak insight, they had managed to get their month-end reporting from I think it was weeks down to 19 hours on a beautiful machine on site. We did that lift and shift, did a benchmark, got it down to 2 hours, 45 minutes. Instead of 64 cores, 256 gigs of RAM, we were running 4 cores, 16 gigs of RAM. We increased the cores to 6. So we're running 6 cores, VMs, on Google. We got it down to 1 hour, 45 minutes. The same environment. Now, what's the win there? Well, it's faster. You're getting the stuff in. You're paying less on your compute environments. That's why I say when you take pricing calculators and you compare like for like that way, you are failing. The hyperscalers have built incredible architecture that scales infinitely. So go and try it. It takes maybe 2 weeks. Go forth and benchmark. The second one is, I love seeing guys who try to do the Hadoop play. I feel sorry for the data scientists who were hired to then do data engineering work. Now, for those of you who don't know the difference between data engineering and data science, a data science is the brains. These people are literally wearing white coats. They're phenomenal skills. A data engineer, and at SciTech, we're mainly data engineers, we refer to ourselves as the plumbers. We do the dirty job. The dirty job of trying to fix the silos in your organizations, pull the real-time data streams into a big data environment. And guys, the reason why you can do it nowadays and not back then is because you had limited compute, so you had to run batch jobs, and batch jobs got things out of sync, so it was a complete disaster. Now you can pull it in real time because the compute is cheap, the storage is cheap, and you start modeling out on these big data environments. Free up your data scientists to then work on the machine learning elements. Use the data engineers to build the pipelines, guys. So start building pipelines. And guys, we're talking about weeks worth of effort. I've met so many people who are so worried about the data integrity from the current environments. Just go and start doing it. Pick an area, a problem that you wish to solve. Pull the right data sets together, visualize it, start asking questions of that data set, and then start adding the layers of the different data environments that you want to include in these big data Hadoop stacks. Well, sorry, not just Hadoop, but Hadoop is massive, guys. Hadoop is this huge sledgehammer that we're using to smash a little problem with. There are many other big data databases or flat file data environments that do the job. I often sit with clients who have invested years in building Hadoop environments. And in the meeting, for fun, we listen to what the spec is, the kind of templates that they're running, Spark in the environments, cool. We replicate it in the meeting and fire up the same amount of workload and capacity in 5 minutes. It's not that much fun if you spend 2 years trying to figure it out yourself. But guys, that's the technology. I mean, all the cloud providers have it. Google's is called Dataproc. It sets it up in an instant from a template. And you attach compute and storage and off you go. Problem solved. It's not that difficult, but we seem to overcomplicate things. And then the final step. Step 3. Everything can be lifted and shifted. Start with that. Take a system, but don't just do half and hope to make it work across this hybrid environment because you're worried about the investment that you've just put down there and you want to take the entire system, put it up there. Otherwise, you're mucking around trying to figure out the latency issues, timeouts, all these kind of things. You do it by system, and it is quick. Like I'm going to use PPS as an example. I love the story. They moved their whole dev environment and they had a culture problem. Because the culture problem was everyone wanted to keep on doing things the same. We want to do it on a Microsoft environment. So what we did is we moved everything over the weekend. Took about an hour. I think it was 60 machines, Windows machines. You're still working on the same environment. It was a snap. We configured the AD environments, configured the IP addresses. The traffic's all sitting in, or the workload's all sitting in Belgium. And then we said nothing. We cut it over. The IT ops manager, Teddy, brave, says, we're not going to tell him. We'll just keep it quiet. Let's see what everyone says. So 2 weeks passed. They sat the full team down. They said, what do you guys think of the environment? Everyone went, yeah, no, not bad. Shall we move to Google? They all went, yeah, no. This is running faster than it's ever run before. It's more stable. It's amazing. Why do we want to move to Google? And that's where you broke the news. You've been on it for 2 weeks, guys. So try these platforms. Don't sit there and assume. Benchmark, lift and shift. The only infrastructure you cannot lift and shift. Anyone want to guess? Anything pre-x86, 32-bit environments. Mainframes. If you are there, I've got great news for you. You are screwed. So some sage advice. Trust me, I've been there. I've worked with the banks. It's a hard decision. Just take this advice. You've got 2 options. First option, start recoding if it's your own code that you've built and you're stuck on these legacy platforms because the COBOL developers are dying soon. Recode into this modern environment. I used to code in COBOL. I went into the bank. I nearly got a pay increase. Young man. No Walker. Fantastic. So start recoding or go buy a new system. Make it your number one priority to do that right now. Option 2, what you try to do. So I don't think you have 2 options. Just my sage advice. So guys, you have a year now. I challenge you to understand where you are going and pick either some plans around data or around machine learning or lift and shift or modernize your compute stack into containers. That's what I should have told you in the last one, I forgot. Really important, because that's where it's going, right? You need to make it mobile. Get yourself there. We are not talking, this is going to take a year or 2. And I love PPS guys. Are the PPS guys even here? I don't think they are. They were here last year. Took them 9 months to move absolutely everything. I'm not saying you're going to move absolutely everything. Everything has gone up there. There's not a piece of infrastructure that they're using in production or test that's not there. So it's debunked the myths around regulation, around POPI, around latency. So my advice is try it. And this is not going to take you a year. You should be planning weeks, not years. That's how evolved this technology is. So on that note, now you guys are able to unlock your businesses to be able to start a new business model in this abundant world, because compute is abundant now. Thank you very much.
Young man,
Slim man.
why do you have such negative things to say about banks and the mainframes? What's your problem that you have with Hogan?
I'm so impressed you know that.
No, well,
Did you learn COBOL?
No, but FNB still use Hogan. You know, they've got this machine sitting somewhere that's running some of the applications. It's most bizarre. But you know, you mentioned about moving a lot of those stuff, you know, those things, and you said, you know, next year and this year. But is it really that easy to move those legacy applications across?
It is. I mean, left in that world. So the lift and shift is easy, guys. It happens in weeks. You need to rethink your network. I didn't talk about that. Really important. MPLS, breakout. Get it out. Get it into the cloud. Secure it. Everything's encrypted in transit and everything. So it's super easy. By the way, I want to try something.
Yes.
Can you put my deck back up?
Right. What are you going to
I just want to see if this works.
Okay.
Okay, do you mind?
Oh, you want to see if your QR code's going to work?
Yeah. Guys, last year, did you do it? Did it work?
Did it work?
Okay, guys, can you take your phone? If you have my time to spend with you for free, to be able to help you with your plan for free. So please take out your QR code. I've put 2 months worth of time there in a certain amount of time. You go pick a date, it's in blue, and then it'll log it and put it into our calendars together. And it just sorts it out. And then I'm not inundated. And everyone always comes up to me and says, geez, Brett.
So a free hour?
A free hour, yeah, of my own time. And my excuse is it's never in my diary. So let me know if it works. Give it a bash if you want to have a chat.